Yesterday we learned how to calculate molar mass, and we talked a little bit about a conversion factor called Avogadro's number. We also learned about the mole. So today what I want to do is introduce you to how we use dimensional analysis in chemistry to perform stoichiometry calculations. Stoichiometry is just a big fancy word for conversions, coming from the Latin word stoichion and metri. This is sometimes called the factor label method as well. So if you hear it referred to as the factor label method, dimensional analysis, same thing. All right, so um, when you are reading your problems that we're going to look at for our examples in a few minutes, um, some things you want to look out for. You're going to be seeing words such as moles. Remember, that's our SI unit for our amount of our substance. You might see grams or mass. You might also see molecules, atoms, or formula units mentioned. Remember the molecules, atoms, and formula units. These are just our representative particles. We learned yesterday that molecules refer to molecular compounds, atoms refer to just elements, and then formula units is specific to an ionic compound. But when you see any of these units, it's talking about our representative particles. Our one-step conversions that we're going to be looking at in our Chapter 10 notes will always involve going from moles to grams or grams to moles, moles to our representative particles, or representative particles back to moles. But one thing that you will always notice if it's a one-step problem, if you see the word moles, then that's one of the ways you can know it's a one-step setup. So when I say one step, what I'm referring to is it needs one conversion factor. If you recall back from Unit 2, when you were first introduced to dimensional analysis, I told you that whenever you read your problems, you want to always start by writing down your given with its units. Then you're going to draw your T-chart. And in this area here, this is where our conversion factor goes. This is our conversion factor. Now, in the problems we're going to look at today, our conversion factor will either be the molar mass that we learned how to calculate yesterday, or it will be Avogadro's number. Now, the units are very important to being successful at setting up a problem like this because your units have to cancel. Remember, anything on the top or that is side by side, you multiply. Anything on the bottom, you're dividing by. This is considered our denominator. I typically shade this area in because for the problems we're going to be doing, there will be no denominator in our given. You will notice your units cancel, they divide out, okay? And you're left with a unit you're desiring to find. You will end up, once you do your calculation, your answer, along with the unit and the correct significant figures will be expressed here. Try to box in your answers so that it's clear that that is your final answer. This is always your conversion factor. So as I said a few minutes ago, it will either be molar mass or Avogadro's number. Now, before we do some of our calculations, I want to talk to you about just some helpful hints for these calculations we're looking at today. First of all, when mass is mentioned in your problem, if you see mass or grams, the unit grams, then that means that what you're going to need for your conversion factor is the molar mass. Now, if you recall from yesterday, when we talked about molar mass, the molar mass is going to have, when you calculate it, the number will always be beside the unit grams, and it's always grams per 1 mole. Now, this is always per 1 mole. So understood 1, it's like a counting number. Now, in the event that you need to divide by the molar mass, just so you can see how this would look, you might have to take this and take its reciprocal. So the reciprocal of this would have 1 mole on top and your molar mass with the grams on bottom. So this is like your molar mass conversion factor, what the unit would look like. And I just want to emphasize to you that the moles will always have a 1 beside of it. If when you read your problem you see the word moles, If it's mentioned anywhere in the word problem, that's how we know for this chapter 10 anyway. That's how we know it's going to just take you one step. It's a one-step conversion. That will help you in setting the problem up. The third and final hint here, a very helpful hint, is when you read your problem, if you see molecules, atoms, or formula units mentioned, remember these are our representative particles. So if you see molecules, atoms, or formula units mentioned, then we're going to be using Avogadro's number as our conversion factor. Now remember Avogadro's number, you don't have to calculate this. This has unlimited sig figs because it's not a calculation, and it will either be plugged in as 6 times 10 to the 23rd, I'm going to just put representative particles, over 1 mole, or if you need to divide by it, you'll have your 1 mole on top. Take the reciprocal of this, 6 times 10 to the 23rd representative particles will go on bottom. So if you see moles in your problem, it's a one-step conversion. If when you read your problem, if you see mass mentioned, then that means you're going to have to calculate the molar mass and use that as your conversion factor. And if when you read your problem, if you see any of your representative particles, molecules, atoms, or formula units, then the conversion factor you need is Avogadro's number. All right, so in the next video, we will be working through some examples. You will need your periodic table and your calculator and your worksheet.